Hello everyone, welcome to another video on differential calculus, and in this video I'm going to be focusing on the 2024 Maths Paper 1 Grade 12 Final Exam RSA, that's Republic of South Africa. And I'll be looking at question number 8 because it actually covers what we've looked at so far. Right, question number 8 says here 8.1, determine the derivative with respect to x of 3x minus 5x, that 5x squared, that's 8.1.1. 8.1.2 says we must determine g prime of x if g of x equals 2 over x squared minus cube root of x power 7. And then 8.2, it involves equation of a tangent. 8.3, first principles. And then 8.3.2, it deals with functions, basically domain restriction. And this one also, it's on the same concept of domain restriction. So total number of marks, 18 marks. Right, so let's go straight into it then. 8.1, we're supposed to differentiate with respect to x. Now when a question is written like this and it's 2 marks, we cannot use first principles, it will be a waste of time, so we have to use rules of differentiation then. So our answers will be as follows. Question number 8 we're dealing with 8.1 and then 8.1.1 says the derivative with respect to x of 3x minus 5x squared. Now this is exactly equal to, you differentiate this part here, the derivative of a constant times a function is equal to the constant times derivative of a function. So derivative of x is 1 times 3, it will be 3. So let's just write 3 times 1 here, minus 5. The derivative of x squared is 2x. Of course, 2 power 2 minus 1, so it will be 2x. Simplifying this, it gives us 3 minus 10x. Right, so that's our final solution. Now, please take note of the fact that derivative of x is 1. You can actually use the rules of differentiation of first principles to verify that. And also derivative of x squared is 2x. You can also use rules of differentiation of first principles to verify that. Let me just quickly do that using rules of differentiation. It's much easier. So we are saying derivative of x. If I say y equals x, what do I mean? I mean x power 1. Let's use power rule, which says dy dx will be equal to n x power n minus 1, if you are told that y equals x power n. Now here we see that the power is 1, so we can say dy dx will be equal to, take the 1, multiply, and then x power 1 minus 1. So what is this? This is 1 times x power 0. What is x power 0? It's 1. What is 1 times 1? It's 1. So the derivative of x, which is x power 1, is actually 1. Let's also try and show that y equals x squared. What is dy dx? Dy dx will be, using power rule, x power 2 minus 1. Using power rule, so this is 2x, because x power 1, basically this is actually 2x. So this is what I was trying to explain in this one here. The derivative of x squared is 2x, derivative of x is 1, and when you simplify, that's what you get. Mark distribution, where this one is 2 marks, so you have 1 mark for that and 1 mark for that. And this mark here is for the minus 10x. That mark is obviously for 3, so that's 2. Let's move on to question number 8.1.2. 8.1.2, here it is. 8.1.2, it says we must determine g prime of x if g of x is 2 over x squared minus cube root of x power 7. So 8.1.2, 8.1.2, it says g of x is equal to 2 over x squared minus cube root of x power 7. So the trick here is to first of all rewrite these two terms as powers of x. So it will be as follows. This implies that g of x is equal to 2x power minus 2 using laws of exponents minus x power 7 over 3 using laws of exponents. Right, now we can differentiate this now. So we're going to say therefore g prime of x, using the rules we've done so far, 2, and here you have minus 2 and the x minus 2 minus 1 minus, there it will be 7 over 3 x power 7 over 3 minus 1. Now simplifying this, we are going to have minus 4 x power minus 3 and then minus 7 over 3 x power 7 over 3 minus 1 is actually supposed to be 4 over 3. You can actually check here. 7 over 3 minus 1, the answer is 4 over 3. Right. Now, respecting the format in which the question has been presented, we have the radical sign there, and then we have a positive exponent of x. This would be rewritten as follows. You'd write this as minus 4 all over x cubed, and then minus on the top there, remember you have to have 7, and this part here is actually cube root of x power 4. So 7 cube root of x power 4 and all over 3 here. This would be the final solution as far as this question is concerned. However, during the marking process, they're not very strict whether you respect the format in which the question has been presented or not. So how are the 4 marks distributed? Here we have the 4 marks. See, how are these 4 marks distributed? This is how these 4 marks are distributed. 1 mark will be for rewriting that expression in that format. 1 mark will be for rewriting that into that format. And then 1 mark will be placed here, that term. And then 1 mark is going to come there. So in other words, you don't get any mark for this, but it shows that you understand what differentiation is all about. Right. So you have your 4 marks for that. You have 4 marks for that. Now let's move on to question number 8.2. 8.2 involves equation of a tangent. We're told we're supposed to determine the equation of a tangent to f of x equals x cubed minus 4x squared plus 2x plus 3 at x equals 2. Right. So equation of a tangent, we need a point, and we also need the gradient or slope of the tangent. So let me capture this. 8.2, we are told f of x is equal to x cubed minus 4x squared plus 2x plus 3. We are told at x equals 2. So we know we need a point, so we're going to say y is equal to f of x, which is equal to x cubed minus 4x squared plus 2x plus 3. Now we're going to say at x equals 2, what will y be equal to? Y will be equal to, put 2 there, 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 and there. Y will be equal to f of 2, which is equal to 2 power 3 minus 4, 2 power 2 plus 2 times 2 plus 3. What does this say on the calculator? Well, on the calculator it says 2 cubed minus 4 times 2 squared plus 2 times 2 plus 3. The calculator says minus 1. So we have a point then, and this point is x is 2, y is minus 1. That's the point we have. So we're going to call this x1, and then we're going to call that y1. The point is determined. So next is to work out the gradient of this tangent. And if you remember my very first lesson on differential calculus, I said the gradient of a tangent is called derivative, and the process of determining the gradient of a tangent to a curve is known as differentiation. So here we have to differentiate to determine m tangent. So I'm going to say therefore m tangent is equal to f prime of x. So what is f prime of x? From there, using rules of differentiation, that expression there gives us 3x squared minus 8x plus 2. And 3, derivative of a constant is 0, remember? So the 3 falls off. Derivative of x cubed is 3x squared. Of x squared is 2x times 4 is of course 8x, but there's minus there. You have to respect that. Derivative of x is 1 times 2 is 2. Now, we're going to say, therefore, at x equals 2, what is m tangent? It will be equal to, substitute 2 there, f prime of 2, which is equal to 3 times 2 squared minus 8 times 2 plus 2. What does this say on your calculator? Let me write it over here. What does it say on your calculator? Well, let me punch it in. So we have 3, open brackets, 2, and it's squared minus 8 times 2 plus 2. The calculator says minus 2. That's our gradient. So we now have the gradient and we have the point. So we can use Poinsot formula to determine the equation of a tangent as follows. Equation of a tangent, we know the Poinsot formula says y minus y1 is equal to m x minus x1. Remember, y1 is minus 1, so we're going to say y minus minus 1. Always use brackets when you're substituting. What is m? Minus 2. Always use square brackets here, because this inside there you are going to need small brackets like so. What is the value of x1? It's 2. It won't always be positive, sometimes it will be negative, and therefore these brackets here will prove very, very useful. So on the left hand side is y plus 1 is equal to, on the right hand side is minus 2, one step at a time, x minus 2. Removing those brackets there, y plus 1 equals minus 2x plus 4. Subtracting 1 from both sides, you're going to get y is equal to minus 2x plus 3. And that's your final solution. Right. How are the 3 marks distributed? Remember, this question has 3 marks, as you can see here. 3 marks. The 3 marks are distributed as follows. You're going to have 1 mark for the value of y there, and then you're going to have 1 mark for the gradient, and then you're going to have 1 mark for the final answer. So in other words, the value of y, gradient, substitution of the 2 into the formula, and then determining the final solution. So that will be 3 marks. Right. Let's move on to the next question there, which is question number 3, 8.3. And in 8.3, we are going to focus on what we call first principles. You can see here, 8.3, we are told f of x equals minus 6x squared. And 8.3.1, we're supposed to determine f prime of x from first principles. And that's 5 marks. Right, so 8.3, and then 8.3.1. But we're given there, what are we given? Remember, the entire of 8.3 is based on the fact that f of x is equal to minus 6x squared. And now we're supposed to, in 8.3.1, determine f prime of x. So we're going to go straight and say, we know that f of x is equal to minus 6x squared. Therefore, f of x plus h, this will be equal to minus 6, and then x plus h, we have to square that. And this, from the previous videos, you should remember that I told you that this is x squared plus 2xh plus h squared. Practice makes perfect. Get used to practicing, and then these things will be mastered automatically. You don't have to force anything. Expanding this, it will give us minus 6x squared minus 12xh minus 6h squared. Going into the formula, therefore, we know that f prime of x says limit as h approaches 0 of f of x plus h minus f of x all over h. Substituting the two expressions, this one and that one, into the formula, we can say this is equal to limit as h approaches 0 of minus 6x squared minus 12xh minus 6h squared minus, remember you must always use brackets here, minus 6x squared coming into the brackets there, all over h. Removing the brackets, we have this is equal to limit as h approaches 0 of minus 6x squared minus 12xh minus 6h squared plus, remember that this sign has to change, 6x squared all over h. You see that these cancel. What is our next step? Limit as h approaches 0 of minus 12xh, and then we have minus 6h squared all over h. Now I'm going to write this minus sign a little lower here. It's a bit too high for my liking. I'm going to write it there. Right. Factorizing the numerator, what we have is limit as h approaches 0 of h open brackets minus 12x minus 6h all over h. All over h here. My hand is misbehaving again. All over h down here. All over h, and then I'll come back there and fix that. And obviously, like I said, the h cancels. This h will cancel the h that I'm going to write down here, and a final but one step, limit as h approaches 0 of minus 12x minus 6h. And you notice as h approaches 0, the minus 6h will approach 0, and the only solution we're going to have is actually this expression here, which is minus 12x as our final solution for this one. I'll show you how the mark distribution is carried out. Let's do the mark distribution before I fix that. Mark distribution, we're going to have 1 mark for this expression here, 1 mark for substitution into the formula of the two, this one and that one there, and then 1 mark for simplifying, and then 1 mark for the common factor and cancelling, and 1 mark for the final answer. Be careful, question number 5 is where they deduct a mark for incorrect notation. So be careful there. Incorrect notation, remember this h cancels that h up there. Incorrect notation would be, for example, when you put the equal sign outside of this, putting the equal sign between this and that, putting the equal sign there instead of the equal sign at the beginning there. So just practice using this and you'll see how this comes out so nicely like that. All right, let's move on. So that's 5 marks. 8.3.1 completed. Now if we move to 8.3.2, it's now functions. 8.3.2 basically dealing with functions. Here it is. We have the same expression or same function, but we're supposed to explain how. Here it says write down how you will restrict the domain of f such that f inverse, or f to the minus 1, the inverse of f, is a function. So we all know, at least from your grade 11 knowledge, you know that inverses of quadratic functions are not functions. However, if you restrict the domain of the original function, then you obtain two parts of the same quadratic function that are both functions. So in this case, we're required to determine the inverse. Here it says we must write down the how we would restrict the domain of that so that the inverse is also a function. So domain restriction, 8.3.2, 8.3.2, we know that f of x is equal to minus 6x squared. Writing it in standard form, this, if you remember, it will be minus 6x squared plus 0x plus 0. Why am I writing it like that? Because the standard form of any quadratic function must always be f of x is equal to ax squared plus bx plus c. Now, if you don't have the terms containing x and c, it means the coefficients are 0. Of course, the last term, the constant term, will be 0 there. So that tells us that at turning point, which is at TP, which is what we need to do, x equals at TP. I'm going to write here at turning point. At TP, x must be equal to minus b all over 2a. Let's substitute here. And we have minus, remember b is 0 there. If you remember this format here, the coefficient of x is 0 and the coefficient of x squared is a. So in this case, we're going to say all over 2 times minus 6. That's the value of a. And if you simplify, this will be 0. As far as domain restriction is concerned, the original function is domain of original function can only be restricted from minus infinity to 0 or from 0 to positive infinity. So we're going to say here, therefore, x must be an element of all numbers from minus infinity all the way to 0, or from 0 all the way to positive infinity. They are looking for that one for 1 mark. I have had to do the calculations here because some people will be coming across this for the first time and they may not know that this is what you do. So whatever quadratic function you have been given, determine the value of x at the turning point, and then the domain will be restricted from minus infinity to that value of x, and then from that value of x to positive infinity. Right. So this is just 1 mark. That's just for accuracy, 1 mark. If you make a mistake on the sign or anything else, you're going to lose that mark there. Right. Let's go to the last one, 8.3.3, which basically is saying that we must write here, determine the equation of the inverse, and they are only interested in the part where the inverse is below x-axis. That's what it means to be less than or equal to 0, below x-axis or on x-axis. So let me just explain something there. So basically what I'm saying to you is the function y is equal to f of x, which is equal to minus 6x squared. This function, the sketch of it must be like this. You have x-axis there, y-axis there. The sketch must be concave down like so, if you remember your grade 11 work. And therefore the inverse of this will be that one there. That will be the inverse. If the coefficient of x squared is negative, the inverse faces to the left. If it's positive, it must face to the right, and obviously the original will be up. So basically I'm saying there are two formats. It's either this one here, or if I had y is equal to g of x, let's say, and this is equal to positive x 6x squared, the original graph would be as follows. The original graph would be as follows: concave up, and the inverse will be facing to the right. You can verify these by sketching those. So this is what you're going to have here. So their interest is this one. This is where their interest is. And you must notice something. This graph of the inverse here has two parts. It has the top part. Let me use a red color. Top part. And then it has the bottom part. This part here. Right. So let's determine the inverse function then. So this is 8.3. I'm gonna come back to that graph. So 8.3.3, we know that f of x is equal to minus 6x squared. Step number 1 says replace the function by y. Step number 2 says swap x and y. Step number 3 says solve for y. So bring this expression to the left, you get this. Take this one to the right hand side, you get this. Divide by 6 both sides, you get y squared equals minus x over 6. And then determine the value of y. You're going to get y equals plus or minus, obviously it's a quadratic function, this is what you must get, all over 6. And we know that x must be negative or 0, otherwise this expression here will not give you a real number value, this part. Now you see there are two functions basically here. It's plus and minus. The plus one is the top part. So this is the one we're saying it's plus. Y equals positive square root of minus x over 6. There, positive square root of minus x over 6. This bottom part here is y is equal to minus square root of minus x over 6. This is what the examiner wanted. So we're going to say, therefore, for y is less than or equal to 0, we are saying we have y equals minus square root of minus x over 6. And of course, don't forget to say that x must be that. This is what they are looking for. They were looking for in this exam and on that specific question. I want to emphasize that here you have two functions, almost, that part and that part. So restricting the original domain, this is what you get. For the sake of this video, I'm not going to go into details explaining that. It's explained in the lower grade, grade 11. Maybe at a later stage when we start revising functions, we're going to go through that. So, but this is what they were looking for. And you had 3 marks for that. The total number of marks for this specific question, it will be 1 mark plus 3, that's 4. That functions there. They always add something on question 8. So how are the marks distributed? The 3 marks will be distributed as follows. Please take note of this. 1 mark will be for swapping x and y. 1 mark will be for determining that. Sometimes they include this, but most of the time they don't. And then 1 mark is going to be for the correct choice with a minus sign there in front. That correct choice there. You get 1 mark. So that will be 3 marks altogether. All right, I'm going to stop here in this video. I will come up with another video where I'll be talking about basically the same concepts. I'll focus, this was 2024. In my next video, I may look at 2023, either the final exam or the preparatory exam. I feel like I must bring up 2 more videos on question 8 or 7. Usually differential calculus comes in question 8 or 7. And then, yeah, I'll move to other rules of differentiation, which is the product rule, quotient rule, and the chain rule for university students. All right, if you're new to the channel, please help us by subscribing and inviting friends to subscribe. It will help us build the membership for the channel, and that will give us the impetus and momentum, like I always say, to make more videos and help as many students as we possibly can. All right, see you next time.